Welcome back, you guys. Your favorite Calculus 2 class. We're going to take a look at power series and functions. So we have a bunch of these uh, tests that we can use for convergence and divergence, right? Now what we're going to do is we're going to study sums that look like infinite polynomials. Okay, we call these sums power series. And I'll let you read through the rest of that in your own time, but let's take a look at the definition of a power series. Okay. So a power series is of this form. You have a sub n x to the n power, and more generally speaking, if it's centered at c, then it'll be of this form, x minus c to the nth power. So let's look at one here on this first one. Let's just recognize who an is and where it is centered at for this first one. I'm going to write this as 1 over n factorial, and this is x to the n. So I'm going to write that as x minus 0 to the n. And that's so that you hopefully will recognize, here's my an part, and here's my x minus c part. So this thing is centered at 0, right? And if you were to expand it, it would look like that. So this is centered. I'm going to talk more about this centering in just a minute. I just want you to recognize right now it's a power series, fits the form, and where it's centered at initially. Let's do that for a couple more here. There's the first one. Let's go to the next one. Can you see how here's my a sub n here, x minus c. So in this case, it'll be centered at -1. Here I've got a sub n as the 1 over n, x minus c. So this one, c is 1. This one's centered at 1. Okay. So let's talk a little bit more about this, these power series. Okay. So it can be viewed as a function. You can view this as a function where the domain is a set of all x for which the power series converges. Okay, so you'll have the domain of a power series will be 3 situations. It'll either be centered at a single point, number 1, an interval, or the entire real number line. Okay. So every power series will converge at its center, and again, it'll be one of those 3 scenarios depending on context. Now, you may be thinking to yourself, well, if n is 0, wouldn't I have 0 to the 0? And so this is a bit of a gray area in math. This is either defined as 1 or left undefined. And here we have this with power series being defined on 1. So it depends on context in mathematics. Again, don't believe people when they say that mathematics is purely black and white. Not always. This is kind of a gray area, so it does depend on context. In fact, if you think about in calculus, if you take the derivative of x to the n, you have n x to the n minus 1. Well, this is valid for n being 1 at x being 0, only if we allow 0 to the 0 to be 1, right? So again, depends on context. So with power series, we're going to allow that to be 1. But let's move into the convergence, okay? So the series will converge only at c. That would be at the single point. So in other words, the radius, there is no radius of convergence. The radius of convergence is 0 here. So that's the first scenario. That's, again, if it just converges at a single point. Or the second one is if it you have an interval of convergence there, okay, about r. So that's number 2. And then finally the third scenario for all real numbers, right? The radius of convergence here would be infinity. Okay, so let's look at some examples here. Let's find this radius of convergence. When you're doing power series, what you want to do first is you want to apply the ratio test with these power series. So what we're going to do is apply the ratio test and see where it converges. So we have n plus 1 factorial x to the n plus 1. This is over the original nth term. So then plus 1 times n factorial. I have x to the n, x to the 1, and factorial x to the n. Notice those will cancel. So we've got limit as n goes to infinity of n plus 1 times x. Let me write that as limit n goes to infinity of n plus 1 times limit n goes to infinity the absolute value of x. Well, this is for a fixed value of x, so I split that up so you see, well, that's going to infinity right there. This is just for some fixed value x. And so we have infinity times whatever x is, it doesn't matter. We just end up with infinity. And so by the ratio test, right, if it's greater than 1 or shoots to infinity, then it diverges, right? And so here we can say, therefore, this power series by the ratio test, this series diverges for anything, right, for any x value, and will converge only at its center. The center, x minus 0 to the n, right? The center is at 0. Only at its center, x being 0, right? Because if you think about that, if this is 0, then we got 0 times that infinity, we have 0, right? Which would be less than 1. So if x is 0, yes, it'll converge. Otherwise, it's going to diverge because it'll be infinity. So it's only for an x value of 0 will it converge. And so the radius of convergence is r being 0. All right, we're going to go ahead and, for this power series, we're going to go ahead and apply the ratio test again. So limit n goes to infinity. Three x minus 2 n plus 1 over 3 x minus 2 to the n. So limit as n goes to infinity, the absolute value of x minus 2, and we just get the absolute value of x minus 2. So, by the ratio test, the power series will converge whenever that is less than 1, right? By the ratio test, we want it to be less than 1 to converge. And so the radius of convergence is r equaling 1. Let's go ahead and apply the ratio test here. So we got -1 to the n plus 1, x to the 2n plus 1 plus 1 over 2n plus 1 plus 1. All divided by the original. So I got x to the 2n plus 2 plus 1, so that's x to the 2n, and x to the third. Bottom I got 2n plus 2 plus 1, so that's 2n plus 3. So I got 2n plus 3, 2n plus 2, 2n plus 1 factorial times. Now this reciprocal. Alright, so we got x to 2n's canceling. I got -1 to the n canceling. I got 2n plus 1 factorial canceling. I got x cubed over x. That'll leave me with x squared. So it looks like we've got limit n goes to infinity. I've got an x. Well, I've got -1 as well. Let me do this. I got absolute value -1, absolute value of x squared over 2n plus 3, 2n plus 2. Absolute value of -1 is just 1. And so for any value of x, the limit, see how n's going to infinity, so this bottom's going to be going to infinity, right? So we got this x squared over this huge number, so the limit will be 0, which is less than 1, right? Which by ratio test, since less than 1, converges for all x. Hence the radius of convergence is all real numbers. Infinity. Alright, so we've talked a little bit about these power series, but we have not talked about is the endpoints. Okay, the endpoints. So we talked about this radius of convergence. So for a power series, radius of convergence is a finite number r. We still don't know about the endpoints, and so we have to test them. Okay, so again, we have the three situations. Number one, either the radius is 0, so it only converges at that c. Number two, it's within some interval, but we don't know if we exclude the endpoints, if we only include one of them, or if we include both of them. So we're going to have to test the endpoints if we have a radius of convergence. And then the third scenario was like that last one where it works for all real numbers x anyway. So the radius is infinity, right? So just keep in mind, we're going to have to test these endpoints. Let's start working on this one then. Let's find the interval of convergence. And let's go ahead and apply the ratio test to start us out. Yeah, x to the n, x over n plus 1 times n over x to the n. Notice our x to the n's cancel. So we've got the limit n goes to infinity. I'm going to write this as n over n plus 1 times the x. So we've got limit n goes to infinity of n over n plus 1 times the limit n goes to infinity of the absolute value of x. Notice here, if I divide everybody by n, this will go to 1. And so we just end up with 1 times absolute value of x. So we just got the absolute value of x. And by the ratio test, converges whenever that absolute value of x is less than 1. And so the radius of convergence is that 1. And we know the series is centered at, right, this, let me go back to the series. This is 1 over n, x minus 0 to the n, right? It's centered at 0. So we have absolute value of x, as long as that's less than 1, it'll converge. Well, what that means is, you know, the absolute value of x is x, or the opposite of x. In other words, we've got to be between -1 and 1. So -1 to 1 is the open interval of convergence, we call that. But we need to check the endpoints. We don't know about -1 and 1 themselves. Again, we know between them it for sure converges. But what about at -1 and at 1? That we have to test individually. So let's test at -1. So we have, this was x to the n over n was our, from n being 1 to infinity. So if x is -1, we have -1 to the n over n. And we can use the alternating series test. Well, with the alternating series test, we're just looking at the non-alternating part. Does the limit as n goes to infinity of a to n equals 0? Yes, it does. Satisfies the first condition of the alternating series test. And does this also work for all n? Does 1 over n plus 1 less than or equal to 1 over n? Yes, that's also true. So, by the alternating series test, this converges when x is -1. Okay, so we're going to include -1 in our interval of convergence. What about at the other end, at the 1? Well, let's let x be 1, x to the n over n. Well, 1 to the n is just 1, so this is 1 over n, and this is p series. So this diverges by p series, 1 over n to the p, where p is 1, right? So if we're less than or equal to 1, greater than 0, we diverges. So it diverges at x being 1. Therefore, our interval of convergence from -1 to 1, but we were including -1. Oh, my bracket's struggling. There we go. -1, not including the 1. Alright, so we applied the ratio test here, and we end up, let's go ahead and start canceling stuff. I got -1 to the n, I got -1, I got x plus 1 to the n, I got x plus 1 to the n, I got 2, I got 2 to the n, and I got x plus 1 to the n. Okay. Plus 1 to the n, those cancel. I got 2 to the n that cancels. I got a -1 to the n that cancels. So it looks like we've got absolute value -1, and I've got an absolute value of x plus 1 all over 2. Go ahead and take that absolute value of -1. Alright, so we've got absolute value of x plus 1 all over 2. And by ratio test, this will converge when that's less than 1. So we have absolute value of x plus 1 over absolute value of 2. Absolute value of 2 is 2. And now I'm going to multiply both sides by 2. And so our radius of convergence is 2. Note the series is centered at -1. So finding the open interval of convergence, let's use that statement that the absolute value of x plus 1 is less than 2. Let's subtract 1 on all sides. And there's our open interval of convergence. So from -3 to 1. But don't forget, we need to check these endpoints for convergence, right? Or divergence. So let's check at -3. So we have -1 to the n, x plus 1 to the n. This is all over 2 to the n. From 0 to infinity. We're going to let x be -3. So we get -3 plus 1 to the n, or 2 to the n. So I got -1 to the n, and I got a -2 to the n. So I got -1 to the n. That's -1 times 2, so that's like a -1 to the n, 2 to the n. Notice my 2 to the n's cancel. And then you've got -1 to the n, -1 to the n. So -1 times -1 is a 1 to the n, which is just 1. Which, by the nth term test, right, nth term says, as long as that's not 0, it diverges. Alright, let's check the other endpoint now, at x being 1. So we got -1 to the n, 1 plus 1 to the n, so I got 2 to the n. This is all over 2 to the n. Hey, it looks like those cancel. So I just got -1 to the n. So this is alternating, right? It goes from -1 to 1 to -1 to -1 to -1 to 1. This is just alternating. So this also diverges at x being 1. You could use, if you wanted to, you see that it does not satisfy the conditions for the alternating series test as well, right? So this will definitely diverge at both of those. So our interval of convergence stays open at both of those endpoints. -3 to 1, not including -3, not including 1. All right, so I applied the ratio tests here. I'm going to start canceling terms. And so it looks like we've got limit n goes to infinity. We've got this n squared over n plus 1 squared times the absolute value of x. So we got the limit n goes to infinity of n squared over n squared plus 2n plus 1. And so this part, that'll give you 1. So you just got 1 times the absolute value of x. And so we just end up with the absolute value of x. And so by ratio test, this will converge. And that's less than 1. So the radius of convergence is 1. And since it's centered is 0, we have this. So the value of x has got to be less than 1 to converge. So my open interval of convergence will be between -1 and 1. We need to check endpoints. So let's go ahead and check our endpoints. So we've got, this was x to the n over n squared. We got -1 as our x. And so I'm going to use the alternating series test. So number 1, limit of the non-alternating part, does that equal 0? Yes, it does. So it satisfies the first condition. Is a to the n plus 1 less than or equal to a to the n for all n. So there's 1 over n plus 1 squared less than or equal to 1 over n squared. That's also true. So it does converge at -1. By the alternating series test. Now what about at 1? X to the n over n squared. So we just got 1 over n squared. So by p-series with 1 over n to the p, with p being 2. So if we have p being greater than 1, it'll converge. Converges at 1 by the p-series. Therefore, the interval of convergence is -1 to 1. We're including both of those this time. Alright, I've applied the ratio test. I'm to the point of canceling my stuff now. I got x minus 6 to the n. Got -3 to the n. Looks like that's it. So we've got limit n goes to infinity. I've got n over -3, n plus 1. I've got an x minus 6. I'm going to write that as n goes to infinity. I've got this n over n plus 1. And then this part, this n plus 1, right? This is 1. take the absolute value of that. So we've got 1/3 absolute value of x minus 6. And by the ratio test, as long as that is less than 1, it'll converge. Converges when that's true, right? So let's go ahead and multiply both sides to get rid of that 1/3 times 3. And there, that 3, there's our radius of convergence, right? So our radius of convergence is 3, and it's centered at 6, x minus c, so 6. And so we have at 6. So there's our open interval of convergence. We need to check endpoints. So let's check 3 first. We've got x minus 6 to the n over n, negative 3 to the n, from 1 to infinity. Most those cancel. So we're just left with 1 over n. And by p-series, it diverges at 3. So how about at 9? X minus 6, I got 9 minus 6 to the n, negative 3 to the n. So I've got 3 to the n over n, negative 3 to the n. So I got 3 to the n, I got negative 1 to the n, 3 to the n. I could force my 3 to the n's cancel. So I got 1 over n. Negative 1 to the n's always. I'm sorry, I've got alternating. Let me take that up top. All right, so I got to use my alternating series test here. So use alternating series test. So number 1 is the non-alternating part. 0. Yes. Is this true for all n? That's also true, and so converges. So by the alternating series test, this converges at x being 9. Therefore, the interval of convergence is, it was diverging at 3, but it was converging at 9. So I've written out my ratio tests here. And it looks like I've got negative 1 to the n canceling. I've got an x to the n canceling. So I've got n over n plus 1. See that negative 1 to the negative 1? That'll go up top and become negative 1 to the 1. So negative 1 to the positive 1. And then I got n over n plus 1. Then I got my x. And this right here, that part will give me 1, right, that limit. So got 1, got limit, and goes to infinity. Absolute value -1 is just 1. So I just got, this just ends up being absolute value of x after all that. Which by ratio test converges when that is less than 1. So the radius of convergence is 1, and the thing centered is 0. So we have the absolute value of x is less than 1, which means between -1 and 1, so our open interval of convergence is -1 to 1, but we need to check endpoints. So we got, let's see, we have -1 to the n minus 1, x to the n, this is all over m. X to the n, all over n. So we got a to the m times a to the n is, actually let me write this as -1 to the n, -1 to the -1, -1 to the n, all over n. Let me do those two. And so that's like a to the n, b to the n is a times b to the n. All right, so I got -1 times -1 is a positive 1 to the n. Well, 1 to the n is always 1. But we got -1 to the and so that's the same as negative times 1 over n. So we can use a p-series, which by p-series diverges with p being 1. So diverges at -1. Diverges at -1. Alright, now let's check the 1. -1 to the n minus 1. 1 to the n. So we got -1 to the n, -1 to the -1, we got 1 to the n. So that'll give me -1 times 1 is -1 to the n all over n. That -1 to the -1 will go down and become -1 to the 1. So we've got -1 and I'm going to use the that'll be -1 to the n minus 1. And so we've got the alternating series test on this. That's true. One over n plus 1 less than or equal to 1 over n. That's also true for all n. So it converges at x being 1 by the alternating series test. So it diverged at -1. So the interval of convergence was diverging and then converging here. We've written out the ratio test here. I'm going to start canceling whatever I can cancel. So I got n over n plus 1. I got -1 squared, which is just a positive. That's a positive 1. And I got a 9, so I got 1/9 x minus 4. This here will go to 1. Right? When this n goes to infinity, divide everything by n there. And so we just end up with 1/9. That's the value x minus 4, which converges by the ratio test and it's less than 1. In other words, there's our radius of convergence. And the open interval of convergence at 4 -5 to 13. We need to check endpoints as always. So we got -1 to the n plus 1 plus n. Well, -1 to an even is always positive, so we just end up with -1 over n. And so we can use P series. One over n to the P. So it diverges at -5 by the p-series. Now let's do it for 13. 13 minus 4 to the n. So we got 9 to the n's canceling there. So we've got -1 to the n plus 1 all over n. So we can go ahead and use alternating series test. Limit that equals 0. Yes, it does. Is that also true? Yes, it is. So converges at 13 by the alternating series test. Therefore, variable of convergence is -5, diverged at -5, and converged at 13. Alright, so we've started this ratio test. And I start canceling stuff. X to the n, x to the n, n factorial, n factorial. So it looks like we've got limit n goes to infinity. I've got 1 over n plus 1 times x. So I've got limit n goes to infinity of 1 over n plus 1. And n goes to infinity of the absolute value of x. Now the limit as n goes to infinity of 1 over n plus 1 is that's 0, right? And so we got 0 times absolute value of x. Well, that's 0. Well, that's less than 1 for all x being fixed values. So by the ratio test, since this was less than 1 for all x, it converges for all x. And so it's all real numbers for the radius of convergence. So negative infinity to infinity is the interval of convergence. So again, it doesn't matter what your value of x is. So we got n fact, whoops, that's supposed to be a n factorial, or n factorials cancel. Oh, thank you, that's, yeah, that's plus 1 there, sorry about that. So we got n plus 1, so the value of x. So, yeah, I can put it this way as well. So this will be, well, this is infinity here, right? So we're going to be either infinity, you know, whenever x is not 0, but if x actually is 0, then we'll be 0. Right? Therefore, this series converges only at x being 0. You know, it diverges otherwise. Alright, I've written out my ratio test. I'm going to start canceling stuff now. -1 squared is just a positive 1 right there. Looks like I've got limit as n goes to infinity. I've got n over n plus 1. I've got, I'm going to take that negative up top, so I have negative a half. And then I've got that x minus 2. And that limit as n goes to infinity of n over n plus 1. That'll be 1. Alright, that's 1 right there. So we've got 1 times 1/2 absolute value of x minus 2. So we got 1/2 absolute value of x minus 2. So as long as that's less than 1, so it converges by the ratio test when this is less than 1. Oops. So the radius of convergence is 2. The open interval of convergence had to be from 0 to 4. I need to check endpoints. That's always positive right there. So we're just left with negative 1 over n. By p series, it diverges. Now I got 4 minus 2 to the n, so I got 2 to the n. So I got an alternating series here. So I use the series test. That's true. It's also true, so it converges by alternating series test at x being 4. So the interval of convergence see, it diverged at 0 and it converged at 4. So I kind of made a little bit of a mess of this, you guys, but kind of written that out. In fact, let me write this down below a little neater here. Limit n goes to infinity. I got negative 1 to the n. I got negative 1 squares is positive 1. I got 3, 7, 11, dot, dot, dot. I keep going up to this 4n minus 1. And I got 4n plus 4 minus 1. Well, that's 4n plus 3. Now I got x minus 3 to the n. At x minus 3 is all over 4 to the n times 4. And then over here I got 4 to the n, I got negative 1 to the n, I got negative 1, I got 3, 7, 11, dot, 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 4n minus 1, x minus 3 to the n. And we're going to start canceling. Negative 1 to the n cancels. Negative 1 squared, that's just a positive 1 anyways. But my 3 cancels. All these cancel, 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 cancel. All the stuff in between to the 4n minus 1 cancels. The x minus 3 will cancel. My 4 to the n over 4 to the n will cancel. And so we've got limit n goes to infinity. I've got this 4n plus 3. I've got an x minus 3. I've got a 4 on the bottom. I've got a negative 1 on the bottom. So, notice this will go to infinity right there, right? So, this thing's going to go to infinity whenever that x is anything but 3, right? But if x is 3, right, that'll cause that to be 0, 0 times infinity, so it will be 0 when x is 3. Therefore, the series converges only at x being 3. It diverges otherwise. So note our radius of convergence, by the way, is 0, and it is centered at 3. All right, just a note. But hopefully that gets you going for power series. Thanks very much for watching. See you next time.